All right. Let's take a look at these 2.5 notes now. So 2.5 are piecewise defined functions. Notice this is piece spelled like a part of something, right? So piecewise defined functions is exactly what it sounds like. These are, you're going to take a piece of this function, a piece of that function, put it all together, and you're going to get one function out of the deal. For instance, such as right here with example 1, we have this piecewise function. F of x is equal to, and then you put the squiggly bracket there because you're going to define each piece. The piece of 4x if negative 2 is less than or equal to x, which is less than or equal to 2. So the only piece of that line 4x is just between negative 2 and 2 inclusive. Also, I have the piece of negative 1/2 x plus 9 if I have the values from 2, which is less than x, which is less than or equal to 4. Oops. Something I want to point out on this is notice x, it's a piecewise function, so x's cannot repeat, right? That's our concept of a function. If 2 counts in this top function because it's or equal to, it does not count in the bottom function because it's just less than. Do you see that? Yeah, so because the x's can't repeat, the bottom one means it's up to, just not including 2, but this top piece does include the 2. Okay, so let's answer some questions about this guy. This is a function, so I am asked to find part A right here, when f is negative 2. Now, the key to a piecewise function is look at the pieces independently. I have this top piece that we're looking at, and we have the bottom piece that we're looking at. So if I want to figure out where is my x value negative 2, and I'm looking at these different pieces, negative 2 is included right up here in this top piece of green. You are not, I repeat, not going to plug this negative 2 into both of those pieces. You only plug into the piece that makes sense, that works. So f of negative 2, if I'm plugging it into this top piece, because then that is the one where it counts, then you solve that. So f of negative 2 is going to be a negative 8. So the coordinate point that I have when f is negative 2 is the point negative 2, negative 8, right? So when x is negative 2 for this function, my output value is negative 8. And remember, the x's can't repeat, so you cannot plug into both of those. You just pick whichever piece the criteria works with. Check out part B. If I have f of 2, again, which one does this work for? I have an or equal sign associated with 2 here, or I just have a less than sign. Does it go for the top or the bottom? The top, yes, because it's or equal to. So again, I'm plugging this into the top. So f of 2 in this instance will be a positive 8. Nice. Let's do part C one more. Check this out. 4. F of 4. Is that going to go into the top or the bottom? The bottom, good, because I have this 4 here. What if I had, well, no. Let's just go with this. So if I have this value, I end up with a negative 1/2 times 4 plus 9. And I noticed on your quizzes, a couple of you put things in terms of decimals. Don't do that. Work with your fractions. So learn fractions and work with your fractions. That's going to be helpful for you. So here, this is the same thing as over 1. So whenever I simplify this, 2 goes into 4 2 times. So what I actually have is f of 4 is equal to this negative 2 plus 9. So f of 4 is 7. Now, there isn't a part D on this particular problem. However, I'm going to make one. So part D here, what if I have f of 3? That is not one of the ends of these parameters, but where is 3? If I'm looking at my criteria. Yes, it is down here again, right? So f of 3 is going to go in this bottom one because 3 fits this criteria. You're always looking at what is that domain. What are the values of x here? Here, x is equal to 3, and so then that's what fits in the bottom. So I have this -1/2 times 3 plus 9. So f of 3 is equal to a -3/2 plus 9. Get that common denominator. So f of 3 here is now equal to this 15/2. Okay. All right. Now the last part of this is we are then asked to sketch the graph and determine if it is continuous. So we've got some graph paper. I'm actually going to take this and rewrite this just so that I have plenty of room here. I've got f of x is equal to 4x if -2 is less than or equal to x, which is less than or equal to 2. And -1/2 x plus 9 if 2 is less than x, which is less than or equal to 4. Okay. I know my x values are going to range from 2 and 4. So let's look at this. I like to put in cheater lines. And we're just going to put in a cheater line so that we can break this off. Here at -2 is a cheater line. -2 obviously is we're working with this. +2 is here and 4 is here. So my cheater lines are going to happen right here at 2 and again right here at 4. I'm going to get rid of those cheater lines when I write my final answer. However, it's nice to have now because I know in between these two pieces, I have y is equal to 4x. And between these two pieces over here, between 2 and 4, I know y is equal to a -1/2 x plus 9. So in between those pieces, that's where those functions are happening. It is helpful, because these are two lines, in order to make those connections. Now, look at what happened. I already have coordinate points. I know when f is -2, the value of my function is at -8, which means I need to fix my graph a little bit here, right? So if I'm at -8, I'm going to make these by 2. 2, 4, 6, 8 negatives. I'll make this +2, 4, 6, 8, just because I'm out of room. So if I have the graph -2, -8, typically I'm going to fix a little bit more here, because typically you don't want to have different scales. So sorry about that. Let's fix this up here a little bit, so I can fix the scale. Since I ran out of room down here, we're going to fix the scale and make everything by 2s. All right. I have the point right here of -2, -8. So I'm going to go -2, -8, and it's going to be right there. There's my first point. And I have the point of +2, +8. Notice this is an or equal to, so both of those are solid dots. +2, +8. And then everything between those. So this first one runs between those. And I know it's a line with a slope of 4, so if we wanted to plug in a few more, then we could. 1, 2, 3, 4 over 1. And I can work with that. Oh, liar, pants on fire. I put a line through there, and that is wrongity, wrong, because my graph only goes between these two values. It does not extend past that. I am starting and stopping when the x values are between -2 and 2. Yep. Okay, good. Now, look at what's happening. I'm going to make this one green just so you can see the difference. F of 4 is equal to 7, or for crying out loud. F of 4 equals 7, meaning I have the point 4, 7. So I'm coming over here to 4 and then up to 7 and making that dot. Because I'm going by 2's, then that sets it up. Now the question here is what is happening at this 2? So what I'm going to look at is what is happening with f of 2 when I plug that into this component. Let's make it bigger so we can see. -1/2 times 2 plus 9. Now the key to this is it is going to be an open circle because I just have the less than symbol. Okay, so f of 2 here is the 2's cancel. I get -1 plus 9. F of 2 is equal to 8 as an open circle. So 2, 8. Here I have this as open circle, but it's in the same place. So really what's happening when I connect those two pieces, the red is the top function and the green is the bottom piece. So I'm taking just those pieces out. Here's my question. Do I have a continuous domain over this piecewise function? Yes. Yes, I do have that continuous domain, and that's where I can put those together. So it does have a continuous domain because they connect. They don't always connect, but this particular one does. Okay, good. There's our first example.